Right now, at this exact moment, an object from beyond our solar system is approaching its closest point to the Sun. It will pass through perihelion on October 30th at a distance of 1.4 astronomical units, just inside the orbit of Mars. Its name is 3I Atlas, the third confirmed interstellar visitor ever detected in our cosmic neighborhood. And according to a wave of reports flooding social media feeds and conspiracy forums across 3 continents, this ancient wanderer has done something that should be physically impossible. It has allegedly captured Earth's Quasi-Moon, a small asteroid designated 2023 FW13, and pulled it into a new orbital configuration. The claim suggests that NASA has entered panic mode, that observatories have gone dark, that something fundamental about our understanding of celestial mechanics has just been violated. Here is what makes that claim fascinating. If true, it would rewrite every textbook on gravitational dynamics. If false, it represents one of the most elaborate misunderstandings of orbital mechanics in recent memory. Either way, the story demands investigation. Because right now, 2 objects with radically different origins are moving through the inner solar system on trajectories that will never bring them closer than millions of kilometers to each other. Yet somehow their simultaneous presence has triggered a cascade of speculation that refuses to die. Let that sink in. The facts begin with detection. On July 1st of this year, the Asteroid Terrestrial Impact Last Alert System, a network of 4 robotic telescopes stationed in Hawaii, Chile, and South Africa, flagged an anomaly. The object was moving at 137,000 miles per hour relative to the Sun, already displaying a faint coma of sublimating volatiles at a distance beyond Jupiter's orbit. That early outgassing, visible when most comets remain dormant and frozen, immediately marked 3I Atlas as unusual. Within 72 hours, confirmation observations came from the Deep Random Survey in Chile, the Lowell Discovery Telescope in Arizona, and the Canada-France-Hawaii Observatory on Mauna Kea. Spectroscopic analysis revealed a reddish dust composition and something stranger, an extremely high ratio of nickel to cyanide in the coma, orders of magnitude above what had been observed in any known comet, including the previous interstellar visitor 2I Borisov. The Minor Planet Center issued the official designation on July 2nd, confirming the object's hyperbolic trajectory with an eccentricity value indicating it originated from outside our solar system. It was real, it was interstellar, and it was active far earlier in its approach than physics predicted for a water ice-dominated body. NASA's Hubble Space Telescope captured detailed imagery on July 21st when 3I Atlas was 277 million miles from Earth. The images revealed a teardrop-shaped cocoon of dust streaming from the nucleus and constrained the object's diameter to somewhere between 440 meters and 5.6 kilometers. The James Webb Space Telescope followed with infrared spectroscopy in early August, detecting carbon dioxide, water vapor, carbon monoxide, carbonyl sulfide, and water ice in the coma. The carbon dioxide signature was unusually strong, suggesting the comet formed in an environment rich in volatile ices that sublimate at greater distances from a star than water does. This explained the early activity but raised questions about the parent system, where 3I Atlas originated, likely somewhere in the Milky Way bulge, a region dense with older stars and complex gravitational interactions. By mid-August, researchers at Pontificia Universidad Católica de Chile, using the Very Large Telescope, had documented extreme negative polarization in the light scattered by the comet's dust, a characteristic unprecedented in any comet on record. The object was behaving like a comet, looked like a comet, but its chemistry and optical properties were outliers even among interstellar objects. Now consider 2023 FW13. This asteroid, measuring approximately 50 feet in diameter, was first observed on March 28th of this year by the Pan-STARRS survey atop Haleakala volcano in Maui. Follow-up observations from Kitt Peak National Observatory and Mount Lemmon in Arizona confirmed its existence, and the Minor Planet Center officially cataloged it on April 1st. But the discovery was not the beginning of the story. Citizen astronomers combing through archival data traced sightings of 2023 FW13 back to 2012. Orbital reconstruction using those historical observations revealed something remarkable. The asteroid has been accompanying Earth in a quasi-satellite orbit since approximately 100 BC and is projected to remain in this configuration until roughly 3700 AD. That span of nearly 4,000 years makes 2023 FW13 the most stable quasi-moon ever identified around our planet. Its orbit is a complex horseshoe pattern that loops around Earth while primarily following a solar orbit synchronized with our planet's year. At its closest approach, 2023 FW13 comes within 9 million miles of Earth. At its farthest, it sweeps out nearly halfway to Mars and Venus. The gravitational influence Earth exerts on this object is minimal. The Sun dominates its motion. Earth merely perturbs the trajectory enough to keep the asteroid nearby in cosmic terms. But the relationship is not a true satellite bond. It is resonance, not capture. Here is where the narrative begins to fracture. The claim that 3I Atlas has pulled 2023 FW13 into a new orbit relies on a fundamental misunderstanding of both objects' trajectories. As of today, October 28th, 3I Atlas is positioned in the constellation Virgo, approaching perihelion 2 days from now. Its closest approach to Earth occurred in mid-July at a distance exceeding 170 million miles. The comet's path will carry it past Venus on November 3rd at a separation of 65 million miles, past Earth again on December 19th at 168 million miles, and past Jupiter in March of next year at approximately 30 million miles. At no point in this entire journey through the inner solar system does 3I Atlas come within gravitational capture range of Earth's quasi-moon. The separation between the two objects has never been less than tens of millions of miles, a distance across which the gravitational interaction is negligible compared to the Sun's overwhelming influence. For 3I Atlas to alter 2023 FW13's orbit, the comet would need to pass within a few tens of thousands of miles at most, close enough for tidal forces and gravitational perturbations to become significant. That has not happened. The physics does not support the claim, yet the story persists. Search social media platforms for the phrase 3I Atlas pulls Earth's quasi-moon, and you will find hundreds of posts from the past week alone, many linking to videos with production values that mimic science journalism but lack citation of peer-reviewed sources. The language is consistent across these posts. Panic mode, gravitational anomaly, NASA silence, orbital disruption. The pattern suggests either coordinated disinformation or a particularly virulent strain of misunderstanding that has found fertile ground in an audience primed to distrust institutional science. Tracing the origin of the claim leads to a handful of YouTube channels and fringe astronomy forums where speculation about 3I Atlas being an artificial object, possibly an Oberth maneuver probe using the Sun's gravity to alter trajectory, has been circulating since the comet's discovery. The idea that an interstellar craft might be capable of manipulating nearby objects feeds into a broader narrative framework where every anomaly becomes evidence of non-human intelligence testing or observing our solar system. Here is the terrifying part, not the claim itself, which is easily disproven with orbital data publicly available from NASA's Jet Propulsion Laboratory Small Body Database. The terrifying part is the timing. 3I Atlas will reach perihelion on October 30th. On that same day, the comet will pass behind the Sun from Earth's perspective, entering a period of solar conjunction that will make direct observation from our planet impossible for approximately 3 weeks. During that window, Mars-orbiting spacecraft, including ESA's Mars Express and the ExoMars Trace Gas Orbiter, will attempt observations from their unique vantage point, with 3I Atlas passing within 30 million kilometers of the red planet on October 3rd. But from Earth, the comet will be unobservable, hidden in the glare of the Sun, until early December when it emerges on the far side and becomes visible again to ground-based telescopes. That observational gap creates a narrative vacuum. It provides cover for claims that cannot be immediately verified or refuted by the amateur astronomy community. it allows speculation to metastasize without the corrective pressure of real-time data. The improbability stack is worth examining. Consider the following independently anomalous characteristics of 3I, Atlas, none of which individually proves artificial origin, but collectively resist easy explanation. 1. The comet's trajectory is aligned within 5 degrees of the ecliptic plane, the flat disk in which Earth and the other planets orbit the Sun. Interstellar objects approach from random directions in three-dimensional space. An alignment this close to the ecliptic is statistically unlikely but not impossible. 2. Ground-based observations documented a sunward jet, sometimes called an anti-tail, streaming from the nucleus toward the Sun rather than away from it. This is atypical behavior. Most cometary jets follow the solar wind and radiation pressure, creating tails that point away from the Sun. A sunward jet suggests asymmetric outgassing, driven by surface topography or subsurface venting, but it remains rare. 3. The extreme nickel to cyanide ratio and high nickel to iron ratio in the coma. Nickel alloys are common in industrial metallurgy on Earth. Their prevalence in a comet is unusual, though not outside the bounds of natural variation in solar system formation chemistry. 4. The timing of the comet's arrival places it near Mars, Venus, and Jupiter during its passage, with perihelion occurring when Earth is on the opposite side of the Sun. That configuration maximizes observational opportunities for spacecraft in the outer solar system while minimizing ground-based Earth observation during the most active phase of the comet's evolution. Coincidence or design? The question is unanswerable with current data. 5. 3I Atlas is approximately 1 million times more massive than the first interstellar object, 1I Oumuamua, and 1,000 times more massive than 2I Borisov, while moving faster than both. Its sheer size and velocity suggest it has been traveling through interstellar space for an immense duration, possibly millions of years, accumulating gravitational perturbations from encounters with stellar populations in the galactic disk. 6. The extreme negative polarization. Polarimetry measures how light waves are oriented after scattering off particles. Negative polarization means the electric field oscillations are preferentially aligned perpendicular to the scattering plane, a characteristic influenced by particle size, shape, and composition. The degree of negative polarization observed in 3I Atlas has no precedent in cometary science. It suggests either a highly unusual dust grain population or surface properties that do not conform to models derived from solar system comets. 7. Archival data from NASA's Transiting Exoplanet Survey satellite captured 3I Atlas in May of this year, 6 weeks before its official discovery, showing the comet was already bright and active at a distance of 6.4 astronomical units from the Sun. That distance is far beyond the ice line where water sublimates efficiently. The early activity confirms that 3I Atlas is dominated by more volatile ices like carbon dioxide or carbon monoxide, but it also means the object has been visible and trackable for longer than initially realized. Pre-discovery observations are common in astronomy, but they complicate the narrative of when exactly 3I Atlas entered the observational net. 8. The comet's inbound trajectory, when traced backward through space, passes within 9 degrees of the sky coordinates where the famous WOW signal was detected in 1977 by the Big Ear radio telescope at Ohio State University. That signal remains the strongest candidate for an extraterrestrial radio transmission ever recorded, a 72-second burst at the hydrogen line frequency that has never been replicated despite decades of follow-up searches. The angular proximity is coincidence in the technical sense. Space is three-dimensional and the signal's origin is unknown. But for those inclined toward pattern seeking, the overlap is provocative. Together, these 8 anomalies form what some researchers have termed a Loeb scale ranking of 4 out of 10, a heuristic developed by Harvard astrophysicist Avi Loeb to assess the likelihood that an object might be of artificial origin. A ranking of 4 indicates significant anomalies that warrant serious investigation but fall short of compelling evidence. It is a call for data, not a conclusion. Now back to 2023 FW13. If 3I Atlas has not gravitationally captured the Quasi-Moon, where did the claim originate? One hypothesis, temporal coincidence. Both objects entered public awareness within months of each other. 3I Atlas was confirmed in July. 2023 FW13, though discovered in March, gained widespread attention in early April when orbital models demonstrated its millennia-long companionship with Earth. For audiences tracking near-Earth objects and interstellar visitors simultaneously, the mental shortcut from two objects in the news to two objects interacting is understandable, if incorrect. Another hypothesis, deliberate conflation. Some sources promoting the claim may be leveraging the genuine strangeness of 3I Atlas to lend credibility to fabricated interactions with other solar system bodies. The Quasi-Moon becomes a narrative prop, a local object whose orbit can be fictionally manipulated without the constraints of interstellar distances. A third hypothesis, observational error or misinterpretation. Amateur astronomers using small telescopes and planetarium software sometimes misidentify objects or confuse their trajectories when multiple bodies occupy similar regions of the sky. If someone observed both 3I Atlas and 2023 FW13 in the same field of view and lacked the training to distinguish their vastly different distances and velocities, they might conclude the objects are influencing each other. But there is a fourth hypothesis that deserves consideration, not because it is likely, but because it frames the epistemological stakes. What if the claim is part of a coordinated test of public and institutional response to anomalous event reporting? In an era where deepfakes, synthetic media, and algorithmic amplification can manufacture consensus around false narratives, the ability to distinguish signal from noise in astronomical data becomes a matter of both scientific accuracy and information security. If a malicious actor wanted to gauge how quickly a false claim about celestial mechanics could propagate and how long it would take for authoritative sources to correct the record, this would be an effective pilot study. The astronomical community's response time, the media's willingness to fact-check before amplifying, and the public's baseline understanding of orbital physics would all be measurable. This hypothesis is speculative, but it aligns with documented attempts to weaponize scientific misinformation in other domains. Regardless of motive, the claim provides a window into three interpretive scenarios. Scenario 1, benign misunderstanding. The story is the product of enthusiastic but untrained observers conflating two unrelated objects because they happen to be newsworthy at the same time. In this scenario, the solution is education. Clearer communication from NASA and other agencies about orbital mechanics, the scales of distance involved in solar system dynamics, and the difference between quasi-satellites and captured moons. Scenario 2, information warfare. The claim is a deliberate fabrication designed to test the resilience of scientific institutions and the public's susceptibility to astronomical misinformation. In this scenario, the solution is vigilance, tracking the origin and spread of the narrative, identifying amplification networks, and developing rapid response protocols for debunking false claims before they achieve critical mass. Scenario 3, signal in the noise. The claim, though wrong in its specifics, points toward genuine anomalies in either 3I Atlas or 2023 FW13 that have not been adequately explained. Perhaps the comet's trajectory has shown deviations from a purely gravitational path, suggesting outgassing thrust or other non-gravitational forces. Perhaps the Quasi-Moon's orbit has exhibited perturbations that standard models do not predict. In this scenario, the solution is investigation. More observations, more data, more rigorous modeling. The evidence currently supports Scenario 1 with elements of Scenario 2. Orbital mechanics is deterministic. Given the positions, velocities, and masses of objects in the solar system, their future trajectories can be predicted with extraordinary precision. The publicly available ephemerides for both 3I Atlas and 2023 FW13 show no intersection, no close approach, no mechanism by which one could influence the other. The Minor Planet Center, which coordinates the discovery and tracking of small solar system bodies globally, has issued no alerts regarding unexpected behavior from either object. The Jet Propulsion Laboratory's Sentry system, which monitors near-Earth objects for collision risk, shows 2023 FW13 maintaining its stable quasi-satellite orbit with no deviations. The European Space Agency's Mars Express and ExoMars Trace Gas Orbiter will observe 3I Atlas during its close approach to Mars on October 3rd, using the high-resolution stereo camera, the color and stereo surface imaging system, and multiple spectrometers. Those observations will provide high-resolution data on the comet's structure, composition, and activity level during a critical phase of its journey. If anomalies exist, they will be documented. What happens next matters. This 3I Atlas will complete perihelion on October 30th, then begin its outbound journey. On November 4th, ESA's Jupiter Icy Moons Explorer spacecraft, currently en route to the Jovian system, will pass within 64 million kilometers of the comet and attempt observations using cameras, spectrometers, and particle sensors. On December 19th, the comet will make its closest post-perihelion approach to Earth at 168 million miles, re-entering the observational range of ground-based telescopes after the solar conjunction blackout. That date is critical. If 3I Atlas has undergone any trajectory changes, outgassing events, or structural breakup during perihelion, December observations will reveal it. The Vera C. Rubin Observatory in Chile, which recently came online and is projected to discover 1 to 2 new interstellar objects per year, will track the comet as it departs the inner solar system. The International Asteroid Warning Network, a coalition coordinated by NASA to improve hazard detection and orbital prediction, has designated 3I Atlas as a campaign target. The goal is not planetary defense in the traditional sense. The comet poses no collision threat. The goal is capability demonstration. Can we accurately predict the orbit of an interstellar object over months and years? Can we perform precision astrometry on a fast-moving, unpredictable target? The data gathered will inform future response protocols for objects that might pose actual risk. On March 16th of next year, 3I Atlas will pass within 54 million kilometers of Jupiter. At that distance, sensors aboard NASA's Juno spacecraft, currently studying the gas giant's atmosphere and magnetic field, may be able to detect the comet in ultraviolet, infrared, and radio wavelengths. Jupiter's gravitational influence will accelerate the comet further, slinging it out of the inner solar system on a trajectory that will carry it back into interstellar space sometime between late November of next year and late January of 2027. After that, 3I Atlas will vanish into the dark, another traveler from beyond the edge of the known, its story locked in the spectra and images captured during its brief illumination by our Sun. 2023 FW13. Meanwhile, will continue its 4,000-year dance with Earth, undisturbed, unperturbed, a patient companion bound not to our planet but to the rhythms of orbital resonance that keep it nearby without ever truly arriving. Here is what to watch for. First, any announcement from NASA, ESA, or the Minor Planet Center regarding unexpected trajectory changes in either object. Such announcements would be accompanied by detailed astrometric data and peer-reviewed analysis. They would not be vague. They would not be speculative. If the trajectory changes, the institutions tracking these objects will say so with precision. Second, the December reobservation window. When 3I Atlas emerges from behind the Sun, amateur and professional astronomers will have a direct line of sight. Crowdsourced observations from backyard telescopes equipped with CCD cameras and planetarium software will flood online databases. If the comet has deployed something, fragmented, or altered course, the evidence will appear in those independent data streams. Third, spectroscopic follow-up from the James Webb Space Telescope. JWST has scheduled additional observations of 3I Atlas in December after perihelion to compare the comet's post-heating composition with its pre-perihelion state. Changes in the gas plume, dust morphology, or isotopic ratios could reveal whether the object underwent processes beyond simple ice sublimation. Fourth, any papers submitted to the astrophysical journal letters, Nature Astronomy, or Science describing non-gravitational accelerations, unexplained polarization shifts, or structural anomalies in 3I Atlas. The peer review process takes weeks to months, but preprints typically appear on the RxIve server within days of submission. Monitor that pipeline. Fifth, behavioral indicators from the scientific community. Astronomy operates on a culture of openness. Discoveries are shared rapidly through the Central Bureau for Astronomical Telegrams and the Astronomer's Telegram service. If something genuinely unprecedented were occurring, the signal would appear first in those channels, not in social media posts or conspiracy forums. Silence from those sources, combined with sensational claims elsewhere, is diagnostic of noise rather than signal. Sixth, outreach communications from major observatories. If NASA or ESA believed there were public confusion about the relationship between 3I, Atlas, and 2023 FW13, they would issue clarifying statements. Watch the NASA Solar System Dynamics website, the ESA Space Science Portal, and the International Astronomical Union's newsroom. Seventh, any reports of amateur astronomers capturing trajectory data that contradicts official ephemerides. Amateur contributions are taken seriously in the astronomical community. If someone presents credible, reproducible evidence of an orbital discrepancy, it will be investigated. The absence of such reports is itself informative. The calendar is precise. October 30th, perihelion. November 4th, JUICE flyby. December 19th, Earth reapproach. March 16th, 2026, Jupiter flyby. Between now and then, either the claim that 3I, Atlas has captured Earth's quasi-moon will be decisively refuted by continued observation of both objects maintaining their predicted paths, or it will be vindicated by data showing an interaction that current models cannot explain. The probability strongly favors the first outcome, but probability is not certainty. Science demands that we remain open to evidence that challenges assumptions, even as we maintain rigorous standards for what constitutes credible evidence. This brings us to the deeper question, the one that animates not just this story, but the entire enterprise of searching for and studying interstellar objects. Why does a comet from beyond the solar system, exhibiting genuinely unusual characteristics, immediately trigger speculation about artificial origin? Why does the discovery of a quasi-moon with a millennia-long orbital resonance get weaponized into a narrative about gravitational capture that violates known physics? The answer is twofold. First, we are wired for pattern recognition. Our brains evolved to detect agency, to infer intention from motion, to see faces in clouds and purpose in randomness. That cognitive architecture served our ancestors well in environments where missing a predator was more costly than seeing one that was not there. But in the context of astronomical phenomena operating on scales of time and distance that dwarf human intuition, pattern recognition becomes a liability. We see relationships that do not exist. We infer causation from coincidence. We construct narratives that feel explanatory but lack evidential support. Second, the question of whether we are alone drives a hunger for signal that can overwhelm the discipline required to separate wish from fact. Every unusual object becomes a potential messenger. Every anomaly becomes a candidate for first contact. That hunger is not irrational. The discovery of even one artifact of extraterrestrial intelligence would be the most consequential finding in human history. It would reframe every question about our place in the universe, our future as a species, our understanding of biology, culture, and technology. The stakes are so high that the temptation to see evidence where there is only noise becomes nearly irresistible, but that temptation must be resisted. Science is not about believing what we want to be true. It is about following the evidence wherever it leads, even when it leads away from the extraordinary claims we find most compelling. 3. Atlas is extraordinary enough without embellishment. It is a time capsule from another star system, carrying chemical signatures of planetary formation processes that occurred billions of years ago in a region of space we will never visit. Its trajectory, composition, and optical properties offer a rare opportunity to study the diversity of solar system architectures across the galaxy. 2023 FW13 is extraordinary in its own right. It is a relic of the chaotic early solar system, a fragment of planetary formation that has maintained a stable resonance with Earth for over 2,000 years and will persist for millennia more. The fact that these two objects are moving through the inner solar system simultaneously is not evidence of interaction. It is coincidence. but coincidence does not diminish significance. These are moments when the universe offers glimpses of its scale, its age, its complexity. The response should not be to fabricate connections that do not exist. The response should be wonder at the connections that do. So here is the answer. Has 3I ATLAS pulled Earth's new quasi-moon into orbit? No. The claim is false. The distances involved, the gravitational forces at play, and the independently determined trajectories of both objects preclude any such interaction. Is NASA in panic mode? No. NASA is in observation mode, coordination mode, science mode. The agency is tracking both objects, gathering data, and preparing to publish findings as the comet exits the solar system and the quasi-moon continues its ancient waltz with our planet. Is something strange happening? Yes. An interstellar comet with anomalous chemistry and optical properties is passing through our neighborhood for the first and likely only time. A small asteroid that has shadowed Earth since the Roman Republic is still doing so, undisturbed, a testament to the clockwork precision of celestial mechanics. Both objects deserve attention, both deserve study. Neither deserves to be conscripted into a false narrative that obscures their genuine significance. If you want to stay on the timeline as this unfolds, as the observational windows open and close, as the data comes in from Mars orbiters and Jupiter probes and ground-based telescopes scattered across every continent, then follow the primary sources. Subscribe to the NASA Solar System Dynamics feed. Set up alerts for publications from the International Astronomical Union and the European Space Agency. Join amateur astronomy communities where raw observation data is shared and debated in real time. The universe is not hiding. The information is available. The tools are accessible. The question is whether we are willing to do the work required to distinguish signal from noise, fact from fabrication, wonder from wishful thinking. So here's the final question, the one that matters more than trajectory calculations or spectroscopic analysis or orbital ephemerides. Is this about contact or pattern seeking? Is the claim that 3I Atlas has captured Earth's quasi-moon a genuine attempt to report an observed phenomenon, or is it an example of the human tendency to construct meaning from coincidence? The evidence argues overwhelmingly for the latter, but the fact that we must ask the question at all reveals something important about our moment in history. We are living through an era when the discovery of interstellar objects has transitioned from theoretical possibility to observational fact. We have now seen 3 confirmed visitors from beyond the solar system. The Vera Rubin Observatory will find more. Within a generation, we may catalog dozens or hundreds of such objects, each one a data point in understanding the formation and evolution of planetary systems throughout the galaxy. That transition changes the conversation. It moves us from wondering whether interstellar objects exist to studying what they can teach us about the diversity of cosmic environments. But that transition also creates opportunity for confusion, for speculation, for claims that outpace the data. The solution is not to retreat from the questions. The solution is to insist on evidence, to demand precision, to celebrate the genuine strangeness of the universe without inventing strangeness where none exists. 3I. Atlas is strange. 2023 FW13 is strange. Their simultaneous presence in our sky is a gift, a chance to study 2 fundamentally different categories of solar system objects at the same time. Let us not squander that gift by pretending they are interacting when they are not. Let us instead ask the harder, more interesting questions. Where did 3I Atlas originate? What can its composition tell us about star formation in the Milky Way bulge? Why has 2023 FW13 maintained such a stable resonance with Earth for millennia when most quasi-satellites escape after mere decades? These are questions with answers. The answers require patience, observation, and a willingness to accept that the universe is under no obligation to conform to our expectations. Right now, as you hear these words, 3I Atlas is hurtling toward the sun at over 60 kilometers per second, its surface heating, its volatiles streaming away, its journey through our solar system entering its final act. Right now, 2023 FW13 is tracing its slow ellipse, indifferent to the comet's passage, locked in the gravitational geometry that has defined its path, since the time of Julius Caesar. They are not touching, they are not interacting, they are simply here, both of them, for this brief moment in cosmic time, offering us a chance to learn. The question is whether we will take that chance or whether we will waste it chasing narratives that feel true but are not. The universe is strange enough. Pay attention to what is real. That is where the wonder lives,